please do not throw sausage pizza away. Where the please is the physical layer, do is the data layer, not is the network layer, throw is the transport layer, sausage is the session layer, pizza is the presentation layer, and away is the application layer. So let's discuss about the first layer. The first layer is also called the physical layer, and it will transform your data into electrical signal or in zeros and ones, and it will send the data through a transmission medium or through a cable or in the air using the wireless communication. We also have the data link layer, and when you think about the data link, you almost right away will see a switch, because the data link is described by switches, VLANs, ARP requests, and MAC addresses. In the data link, the data is measured in segments. We also have the network layer, and the network layer is the third layer of the OCI model, and it will handle the routing, addressing, and it will determine the best path to send your layer 3 packets, because the packets are the measurement unit for the layer 3. All devices which are capable of layer 3 can use the routing protocols, which are OSPF, BGP, ASIS, ICMP protocol, and so on. Also, the data can be fragmented when passing through the layer 3 OCI layer. Basically, we have the MTU, or the maximum transmission unit, and different transmission mediums will handle a specific MTU number, or a device can handle a specific MTU size or packet size for a specific protocol which is using layer 3. So you can fragment the data into a smaller chunks so it can fit the specific transmission layer or the device capabilities. We also have the transport layer, which is described mostly by TCP and UDP protocol. As you know, TCP is the reliable transmission protocol, which will transport your data from one side to another, and it will make sure that the exact copy of the data which you are transporting is reaching the destination. And we also have the UDP, which is faster than TCP, but it does not have reliable transport, because UDP is much faster, and basically it is used in applications where the data do not need to arrive in one piece at the destination. And we also have the session layer, which is managing the control communication between two applications, and it will establish, maintain, and terminate sessions. And the presentation layer, and that will convert the data into a format that an application can understand. For example, your photo viewer will use JPEG or GIFs. Your video player will understand MP4 or AVI or MKV files, or your audio player will understand MP3 files. So presentation is all about the formats that applications can understand. And we also have the application layer, which is basically an interface where you can view the specific data types. Some example of the protocols that are used in application layer can be HTTP, HTTPS for web browsing, DNS so that you can go to internet, SMTP, POP3, IMAP for emails, and so on. So I will give you an example of what layers are used when you transport the data from the green PC, for in this example, to the server one over the internet. So let's go. First of all, you open your browser, Chrome or Firefox, doesn't matter, and you add an address in the browser. So basically you are generating a HTTP GET request to the web page, and this is using layer 7. If you are using HTTPS, you will have the SSL and TLS protocols that will encrypt the HTTP request for the security. This is handled by layer 6. Your computer will also open a TCP connection, and it will establish this connection between your PC and the web browser. The TCP will break those requests into segments and add the source and destination port numbers. For example, it will be port 80 for HTTP or port 443 for HTTPS. And this is layer 4. Your segment is then encapsulated into an IP packet, and the source IP is your PC's IP address, and the destination IP is your web server destination IP address. And all this information is added by the layer 3. Then the IP packet is encapsulated into an Ethernet frame, MAC address, which will be your PC MAC address, and destination MAC address, the router's MAC address are added, and the CRC check is applied. So basically it will check for the errors. And this is layer 2. Now the encapsulated frame will be converted into electrical signal, Ethernet or radio waves if you are using Wi-Fi, and it will be sent to the network. So now that your data has reached the switch, basically zeros and ones are received by the switch side, and this is layer 1. And those zeros and ones will be reassembled into L2 frames. This is layer 2. So since we have a switch, and a switch can understand only layer 2, 1, and 2, and in some cases layer 3 if it is a layer 3 switch. So now that the switch received the data, it needs to send it further down the line. So the frame headers will be changed, and the new source MAC will be the switch MAC address, and the new destination MAC will be the MAC address of the firewall interface. The frame will also be converted into electrical signal and sent to the firewall. This is the layer 1's job. So the electrical signal has reached the firewall. The firewall will convert the electrical signal back into the layer 2 frame. The layer 2 frame will be decapsulated, and inside the layer 2 frame we'll find the layer 3 packet, and since we have a firewall, it will further decapsulate the layer 3 packet, and you will receive the TCP protocol segment along with the port number, which is layer 4. And since we have a firewall, here it's in this image you'll have a Juniper SRX 1500 that can handle data up to layer 4. Now the firewall will send the data to the next device in the internet. Most probably it will be a gateway from your ISP. So basically what is happening, the T6 segments are encapsulated in layer 3 packets. After that, the layer 3 packets are encapsulated in layer 2 frames, and layer 2 frame is converted into electrical signal and sent further. So when the destination network will receive the data, we'll have a firewall, which will be the gateway into the network where the web server is located. So basically, when the destination firewall will receive the data, it will receive electrical signals, and those electrical signals will be converted into a layer 2 frame. The layer 2 frame will be decapsulated. You will obtain a layer 3 packet, and the layer 3 packet will also be decapsulated, and you will obtain a layer 4 segment with protocol and source and destination ports. So now the firewall will send the data to the switch where the server 1 is connected, and TCP segment is again encapsulated into a layer 3 packet. A layer 3 packet is encapsulated in a layer 2 frame, and the layer 2 frame is converted into electrical signals. Now the electrical signal is received by the switch, and it is converted into a layer 2 frame. Based on the layer 2 frame, a switching decision will be made, and the data will be sent to the server, and the frame is converted back into the electrical signal, and it is sent to the S1 using the port connected to server 1. So now the server 1's network adapter will receive bits 0s and 1s, which is layer 1. The Ethernet frame is checked for errors, and it will be passed to layer 3. The IP packet is checked, and if the destination IP matches the server 1, it is passed to layer 4. So layer 4 will ensure that all TCP segments are received and reassembled correctly. Layer 5 will make sure the TCP session is maintained so the web page can load fully. Layer will assure the HTTPS data is decrypted correctly using the server's SSL certificate. And layer 7 processes the HTTP request and generates a HTML response. And the data is sent back to the PC using the exact same order of operations which I described previously. So let's check this table where we have all 7 layers listed. And based on the device, you will see if those layers can be activated or not. A PC or a user computer, it can be Mac, Linux, Windows, doesn't matter, will understand all 7 layers. A switch will understand the first 2 layers, sometimes the first 3 layers if it is a layer 3 switch. A firewall can understand up to layer 5, or it can understand all 7 layers, depends on the firewall. Most of the firewalls will understand to layer 5, and if you have an application firewall, it can understand up to layer 7. The ISP routers, or routers in general, will understand up to layer 3. The firewalls on the receiving side can understand up to layer 7, depends what type of firewall it is. And the web servers usually will understand all 7 layers of the OSI. So thank you for watching. I hope that you extracted some useful information from this video. And I hope that this example of the data transmission will make you understand exactly what the OSI model is and why it is used to describe the operation in a data transmission using a network infrastructure. Thank you, and I will see you in the next one.